Now I would like to bring up a very important aspect of cost. And here I would like to introduce a very old rule that's present in the data space for quite a while, and that's the 1-10-100 rule. And what this basically defines is that, well, if you catch a data quality issue at the point of entry, say you're working with a file that's coming in daily and you catch that, hey, there's something wrong with this file. The actual cost of this particular issue is just, well, replacing the file. Quite minimal, and that's perfectly fine. However, if this particular issue goes undetected and you kind of find it much later, then it's about 10 times. The reason for 10 times is quite straightforward. You have to rerun the process once the file is actually fixed. However, if this particular issue reaches the end user, and say this can be in a BI system, and of course in our use case here, this can be the output of an ML trained system, or maybe it's the training process itself, it's 100 times more expensive because of all the corresponding business consequences that come with it. There's of course customer dissatisfaction, operational disruptions, and a lot more. This is very extremely true in ML systems. As you can imagine, the models that we work with usually are working on, say, 25, 50 node clusters at many points. And again, just the sheer act of running these clusters itself is quite expensive. And so if there are issues in the data present, and while we're trying to run these prediction models, and there are issues in the bare data itself that we catch later on, it incurs huge amounts of costs. And so that's one of the key things. And one thing I do want to clarify here is that the data quality issues found in the training process will not be the same issues you find when you deploy them. And that's one of the key things that, well, okay, when I was working with the model, when I was training it, I saw that, well, I was facing this issue, say, on a particular geography. There was an issue between urban and rural geographies, and I was trying to make sure that the segregation there or the categorization there is done correctly. That's fine. But the moment you publish that particular model and now real data is coming in, you see that this was not completely addressed. We had the system to categorize them, but now the categorization itself is inaccurate. Now we are left with a particular system which is going to send out inaccurate categorization because the rule is not working as intended, and the output cannot be trusted. So the 1-10-100 rule definitely applies to ML, and in fact, I would say that it applies much more truly, and the 100 can also be 500 or 1000 in a lot of cases.